Hi everyone, hope you all fine there. Uh, in previous JE main, that means January mains, more than 22 questions were asked from the thermodynamics. Thermodynamics. So I would like to deal this concept now uh, based on advanced level. Clear? So I'll deal every concept to make you understand well, and it I want to make it to help you for solving the problems in a advanced level, right? So before let's start this content with a basic terminology. Yes, first heat, right? The first terminology is heat. Heat is a form of energy that always transfers from a body at high temperature to the body at low temperature, right? So here let us take two objects. One is at 50 degrees Celsius, another one is at 30 degrees Celsius. If you make them contact in thermally, if they are in thermal contact, then the heat energy will flow from high temperature body to the low temperature body. Clear? So heat is the form of energy that always transfers from a body at high temperature to the body at low temperature. And you must remember that not only between bodies, the heat can flow in a body, parts of the body, when we can find a temperature difference. I mean, for example, there is a huge body with the different parts, right? So and that body, between the adjacent parts there will be a temperature difference, then definitely there will be a heat flow. Whenever wherever you find temperature difference, definitely there will be flow of it when they are in thermal contact. That's very important, right? And when we can see that an object is heated, it means that the molecules of those objects were begin with the greater kinetic energy. They move with greater kinetic energy, they vibrate with greater kinetic energy. Do remember that, right? So this is about the heat. Whereas coming to the units, we can measure in joules or calorie, etc., right? So we'll discuss that also in the next content. And coming to the next terminology is temperature. Temperature, right? If you want to say in a very simple definition, the degrees of hotness or coldness of an object is called temperature. The degrees of hotness or coldness of an object is called temperature. For example, if you take it tells how hot an object is or how cool an object is, right? So and also main important point is the temperature decides the direction of a flow of heat, right? If you observe here, heat is flowing from A to B because A is at high temperature, B is at low temperature. So the temperature of the object decides the flow of heat energy. And coming to the next one more important point is this temperature is directly proportional to the kinetic energy of the molecules or object. And one more important thing is temperature decides the direction of heat. Whenever an object gains heat energy, then its temperature gets rises, right? And in the same way, whenever an object is losing heat energy, then its temperature gets decreased. For example, in this condition, an object B is gaining heat energy, then after certain time its temperature gets raised. Here object A is B is gaining energy, so its temperature gets raised. Whereas coming to the object A is losing heat energy, so its temperature gets decreased after some time, right? So this is one of the important point. What are the points that we have learned? Whatever the object is gaining heat energy, its temperature increases. Whenever the object is losing heat energy, its temperature decreases, right? And temperature is directly proportional to kinetic energy of the molecule. And one more important point is whenever whenever our body is gaining heat energy from the surroundings, we feel hotter, right? Whenever our body loses heat energy, we feel very cool, right? This is what in winter season we feel very cool, and in summer season we feel very hot. In summer season, energy will enter into our body from the surroundings. In winter season, energy will come out from our body, right? So this is the reason for this. So here you must remember that temperature is not the energy. It's just decides the flow of energy. it decides the flow of energy. It tells about the how the degrees of hotness and coldness of an object. And coming to the heat, heat is the form of energy, right? You must remember the difference between these two. Clear? So, and temperature is the one of the fundamental quantity, one of the in seven fundamental quantities. This is one of the seven fundamental quantities, and its SI unit is Kelvin, and dimension formula is theta, right? So now here, after this, you must know one more thing, one more important term, that means thermal equilibrium. Thermal equilibrium. I told you that heat always transfers from high temperature body to the low temperature body. How long does this process takes place? How long it takes place? Here, until both of them gain the same amount of heat energy, the transfer of heat energy takes place, right? So here, after certain time, after gaining both of them same amount of heat energy, the temperatures also become equal. It gets raised to 40 degree, it gets decreased to 40 degree, uh, right? So they both of them will attain the same amount of heat energy, right? And they get the same amount of temperature also, right? After attaining this situation, there will be no transfer of heat energy furtherly. Clear? After attaining the situation, there is no further transformation of heat energy. This situation is called thermal equilibrium. Thermal equilibrium. In the stage of thermal equilibrium, there is no transfer of heat energy because they both objects will maintain the same temperature, right? I mean, the molecules of those objects also will have the same type of kinetic energy, right? This is about thermal equilibrium. And next one is zeroth law of thermodynamics. It's very important. By using this and this equilibrium concept, we construct and we measure the temperature, right? Zeroth law of thermodynamics. Zeroth law of zeroth law of thermodynamics. What is zeroth law of thermodynamics? Let's imagine there is an object A, another object B, and C. Here A and C are in thermal contact and B and C are also in thermal contact, but there is no direct contact between the A and B. After some time, what happens? Obviously, these two objects will reach the thermal equilibrium position, and these two also will attain the thermal equilibrium state, isn't it? So here, what zeroth law is telling that after gaining the thermal equilibrium with these two and these two, even these two also will be in thermal equilibrium. That means these two also will have the same amount of temperature, same amount of heat energy. If AC and BC, excuse me, AC and BC are in thermal equilibrium, automatically AB also will be in thermal equilibrium. Each of them in the thermal equilibrium. Right? This is about the zeroth law of thermodynamics. So by using this thermal equilibrium concept, we can able to measure the a body temperature. For example, when you go to the doctor, he'll check your body temperature by using the thermometer, right? So here, what he'll do, he'll keep contact the thermometer with your body. For example, he'll keep the thermometer under your tongue or armpit, right? So after he'll keep it for some time, then what happens? The heat energy from your body will transfer to the thermometer. Then the length of the thermometer gets increased. So after certain time, that means after gaining the thermal equilibrium with your body, the temperature will be in, the thermometer will be in a thermal equilibrium with your body. Then what happens? After he will remove it and he will check the temperature of the thermometer, which is equals to your body temperature, right? So next, whereas coming to the next concept is uh, the next concept is we'll discuss about the scales of temperature. Scales of temperature. So after this, after learning this scales of temperature, I will go with the construction of thermometer, right? Scales of temperature. Whereas coming to the scales of temperature, there are many scales. Fahrenheit, Celsius scale, Kelvin scale, Ramer scale, right? Even you can also construct on your name. I'll tell the process. If you follow it, you can easily do it, right? So first of all, let us see to construct any scale to measure the temperature, we must need two fixed points. So one is lower fixed point and upper fixed point. Let me write here upper fixed point, right? Upper fixed point. Here basically we'll take water freezing point as a lower fixed point and water boiling point as a upper fixed point. For example, in degree Celsius, in Celsius scale, we consider freezing point of water as a lower fixed point. That means 0 degree Celsius. 0 degree Celsius and 100 degree Celsius means upper fixed point will be boiling point of water, and the number of divisions between these two are 100 divisions will be there. Whereas coming to the Fahrenheit 32 degrees Fahrenheit taken as the lower fixed point means freezing point of water, and 212 degrees Celsius Fahrenheit will be taken as the upper fixed point. The number of divisions are 180. Clear? This is the boiling point of water in Fahrenheit, right? Coming to the Kelvin scale. In Kelvin scale, 273.15 Kelvin as a lower fixed point, 373.15 Kelvin as a upper fixed point. Number of divisions are 100. If you observe here, the number of divisions are same in the degree Celsius and Kelvin. That means the change in temperature is same in both scales, right? So this is about the upper fixed point, lower fixed point, and number of divisions. By using this data, we can able to convert the reading of temperature from one scale to another scale, right? So for example, if I want to convert temperature from degree Celsius to Fahrenheit, then the formula is temperature in Celsius scale minus lower fixed point, right? Lower fixed point by upper fixed point minus lower fixed point, that is equals to constant. For the some other scales it will be same. Temperature on Fahrenheit minus lower fixed point by upper fixed point minus lower fixed point in Fahrenheit. So whatever the, if you substitute the values of those, for example, some x value here and here and here, those values 32 and 212 minus 32 means 180. So you will get the same value as like Celsius scale, right? So by using this formula, you can convert from Celsius to Fahrenheit or Fahrenheit to Celsius. You can convert into Kelvin also. In the Kelvin, there will be temperature in Kelvin Tk minus lower fixed point by upper fixed point minus lower fixed point, right? By using this formula, you can use in Ramer scale also. You have learned already, I think, I hope, right? So you can continue like that. So this is the formula that we have to use. For example, temperature in degree Celsius minus how much it is lower fixed point, 0 by UFP minus LFP, 100 minus 0, 100, that is equals to Tk minus 273.15 by 100, that is equals to Fahrenheit minus 32 by 180. So by using this formula, we can convert from one scale to another scale, right? This is about the scales in temperature. How these scales were constructed. So what we have learned up to now, the scales which we use to measure the temperature, and how can we convert from one scale to another scale. But now we are going to learn how to construct the thermometer, right? How to construct the thermometer. Now Thermometry. This concept is called thermometry. 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 What is thermometry? Nothing but the concept which deals with the measuring of temperature is called thermometry, right? The device which is used to measure the temperature is called thermometer. What is thermometry? The concept which is used to study about the measuring of temperature, right? What is thermometer? A device which is used to uh, measure the temperature is called thermometer. Excuse me. Right now here we use a thermometric property to measure the temperature of the substance. For example, there are many thermometric properties which are there are many thermometric properties of a substance which are varies linearly with the temperature. For example, if you take a small capillary tube, if you take, if you fill with mercury, right? If you raise the temperature, if you give the heat energy, then its temperature gets raised. As you raise the temperature of this mercury, it gets expand, right? It gets expand uh, with respect linearly with the temperature. There is no variation. I mean, right? Linearly, it will expand its length, right? It expands as the mercury expands, its length gets increased. What will we do is, let's think, we'll take length of this capillary tube x naught when the temperature is 0 degree Celsius. After rising to the 100 degree Celsius, here it is 100 degree Celsius, and its length is x 100, right? Now what I want is, I have given some heat energy, then the temperature raised up to here, the temperature raised up to here. At this point, the length is at this point the length is xt. I don't know the temperature. I have to know temperature at this point. Clear? But I know the length. See, what is length here? A linear property of substance, mercury. Okay? Thermometric property of the mercury. Right? So as temperature increases, it expands. Now, I told you the thermometric property of a substance which varies linearly with respect to the temperature can be used to construct the thermometer. Here, as the length is expanding linearly, you know mathematics, right? The mathematics, the formula is y is equals to mx plus c. This is the formula which indicates a straight line, right? Linear variation, right? Here, when the temperature is 0, the length is x naught, x0 plus c. And when the temperature is 100, the length is x100 plus c. When the temperature is T, the length is xt plus c. Let's take it as equation 1, equation 2, equation 3. Right? So now here, if you observe carefully, what I'll do is 3 minus 1 by 2 minus 1. Then what happens? Here Tc minus 1 is 0 by 100 minus 0, that is equals to Tc means mxt plus c minus mx naught minus c, because minus into plus minus, by same way mx100 minus, sorry, mx100 plus c minus mx naught minus C. Now what happens? Tc by 100 is equals to, let me take m as a common, then what happens? xt minus x naught plus c minus c cancel, plus c minus c cancel, and even downwards also. If I take m common, x100 minus x naught, right? So hope you understand this, right? Now what we'll do is, let me write here again. What we'll do is, from this m get cancelled, then tc is equals to, xt minus x naught by x100 minus x naught into 100. Means here we know x naught initial length, and we know x100 means the length of mercury capillary tube at 100 degrees Celsius, and x naught also we know, and at a height of xt. So we have given the heat energy, the temperature rises up to here, right? At this point we have to know the temperature, but we can measure the length, but right, we can measure the length. So by using all these data, you can know the temperature at this point. Formula is Tc is equals to xt minus 0 by x100 minus x naught is into 100. Here I have taken length of a capillary tube, right, which filled with some liquid, right? Some people will take instead of length, we can take pressure of a gas at a constant volume, and we can take a volume of a gas at constant pressure, or else we can take a resistance of platinum wire. Even the resistance of the platinum wire also increases, decreases or increases linearly with respect to the temperature. So all these are called thermometric properties, because pressure of a gas at constant volume, volume of a gas at constant pressure, and resistance of a platinum wire, and also length of the capillary liquid. These are changes linearly with respect to the temperature. As you give temperature, the length increases linearly. The length is increasing linearly. That is why we have used this formula. Otherwise, we cannot. Clear? Right? In the same way, by using those thermometric properties, we can construct the scale. So you can also construct the scale by using resistance of a platinum wire, right? But you have to use this method. I hope it's very clear, right? This is one example for degree Celsius. You can construct in the same manner as a Fahrenheit, or else whatever you want. Clear? So next concept we'll start with thermal expansion, right? Thank you all.